Hello everyone, Dr. Alex Vasquez here with our clinical review of vitamin D deficiency in adults. This is part 3, starting the conversation on anti-infection, and today I'm going to focus on barrier defenses. So let's talk about vitamin D deficiency manifesting as external barrier dysfunctions. Here we'll start with a quick overview of today's topic. Today's focus is on the role of vitamin D in supporting exterior barrier defenses. And so what I'm proposing here is that vitamin D is necessary to support our exterior barriers for protection against infectious disease and also, of course, for maintenance of proper physiologic function. The implication here is that vitamin D deficiency increases risk for diseases by reducing barrier integrity and thereby leading to increased risk of infection and physiologic dysfunction, as we see with dysbiosis-induced insulin resistance, for example. So the focus for today is going to be on the external barriers of the skin and mucous membranes contrasted against the internal barriers such as the vascular endothelium and the blood-brain barrier. So just as I did in part 1 and part 2, I'm going to focus in on biological plausibility and coupling that with clinical evidence. And in this particular conversation, I'm going to try to avoid talking about, for example, gross clinical infections or obvious clinical infections, because that obviously involves other components of the immune and inflammatory response. What I'm going to focus on in today's conversation is simply the role of vitamin D and vitamin D deficiency in either maintaining or failing to maintain those external barriers. So again, focusing in today on biological plausibility, coupling that with clinical evidence. So what are the exterior barriers? And I'm just going to focus on the most common ones that we all think about. We could, of course, look at some others that are maybe less important or less well known, but I think we'll all agree that the following are important: epithelial cells, the underlying immune cells, and then the intracellular junction proteins that connect those epithelial cells to each other. We also are aware of antimicrobial peptides that are secreted onto the skin or onto the mucosal surfaces, lysozyme, secretory IgA, mucus, and the effect that all of that has on various surface mucosal microbiomes. So for example, I think that by now we all appreciate that the gut microbiome has a role in infection, inflammation, and metabolism. So when we look at items here 1 through 7, ultimately that's going to have an effect on the mucosal microbiome. So we want to be aware of that and we want to respect that. And again, like I said before, all of that sounds interesting, especially if you're a histologist or a histopathologist, but I'll make this clinically relevant and show you how it impacts certain diseases. And again, today is only kind of the first part of our conversation on the role of vitamin D in inflammation and immunity. So when I go into more detail on inflammation and immunity in other presentations, we'll kind of have this in the background, and then I can reference back to this while still making progress with newer information. So again, mechanism of action, which is basically the same thing as biological plausibility. We need to see how that manifests in the real world to give us confidence and a reasonable awareness of what we can expect with this particular therapeutic. And again, basing that clinical and therapeutic awareness on the basic sciences of, in this case, the external barrier components. Again, epithelial cells, underlying immune cells, intracellular junction proteins, antimicrobial peptides, and then some other factors like lysozyme, secretory IgA, mucus, also tears and saliva I'll talk about, and then how that impacts the gut microbiome and other regional microbiomes, and then we'll look at how all of that fits together to impact health and disease outcomes. So as I've already said in parts 1 and part 2, I think that vitamin D deficiency must be redefined now. I consider this to be urgent and of the highest importance. Outdated definitions of what constitutes vitamin D deficiency are retarding our clinical and public health progress in addressing the global pandemic of vitamin D deficiency. This is allowing otherwise preventable and treatable diseases to basically scorch the earth with their expense and complications and vulnerability to political manipulation. Doctors and other clinicians need to appreciate the modern science that substantiates the clinical presentation of adult vitamin D deficiency, most commonly presenting, as I've already mentioned in part 1, as pain, in part number 2 as depression, and as I'm starting right now in part number 3, we're going to talk about infection, immune, inflammatory, and metabolic disorders. So again, the purpose of this series of videos is to redefine or appropriately define the diagnosis and pathophysiology of vitamin D deficiency in adults. We need to be looking way beyond the kind of simplistic and outdated perception that vitamin D deficiency in adults only presents as disorders of bone and calcium metabolism presenting as osteomalacia. We need to be way beyond that by this time, and I'm hopeful that this series of videos is going to help a lot of clinicians and researchers and maybe even politicians and the general public get caught up on the science, which again shows that vitamin D plays many roles throughout the body, and therefore as a consequence, vitamin D deficiency contributes to many disorders that we otherwise have difficulty treating, such as pain, depression, infections, inflammatory disorders, and metabolic disturbance. You can see further evidence of this misunderstanding all the way to the present moment when we look at current guidelines for disease management, and especially those that center around the diagnosis of vitamin D deficiency. A quick look at the Preventive Service Task Force recommendation statement for screening vitamin D deficiency in adults, in my opinion, shows it to be completely fraudulent and based on misinformation. So when they codify or otherwise make official their own misunderstanding based on their own outdated perspectives and very selective and inappropriate use of the research, then when that happens, clinicians are going to suffer through their own ignorance, and obviously their patients, their customers, their clients are going to suffer as bad information and these bad recommendations get internalized into what's otherwise called the standard of care. So let's start with a quick quiz so that we can kind of see where we are with the material. Until people are given some type of challenge or a quiz, they always think they understand the topic. Just like if you asked me how a car works, I could have some idea and I could give you my explanation of how a car works. But if I had to explain that to a physicist or an engineer, I think pretty soon we would all be aware that I have no idea how a car works. And conceivably the same thing is true of vitamin D. A lot of people will say they understand it, they'll have some ideas, they've seen a few articles, but maybe they haven't seen, 400 or 500 or 3,000 articles. So let's kind of see where we are with our knowledge of vitamin D. And this is a very quick quiz. And later in today's presentation, I'll give you what I think would be reasonable answers to these questions. So how mechanistically does vitamin D function, and where does it function? How quantitatively does it function? So does it just function on one target, or does it hit 30 targets or 200 targets or 3,000 targets? Like what are some numbers in terms of the volume of impact that vitamin D has on our human physiology? And how does it function? So how physiologically does vitamin D function? What's the absolute minimal cutoff level for serum 25-hydroxyvitamin D3 between deficiency and sufficiency? And just like I said in part 1 video and the part 2 video, we could be off or we could have disagreement within certain percentage points, but let's say within 10 or 20%, we ought to all be on target and in agreement with what is a good cutoff number for optimal 25-hydroxyvitamin D. What's the most common result in adults of administering 400 international units? What's the most common result of administering 800 international units, 4,000 international units, and 10,000 international units? Name 3 nutrients that work closely with vitamin D and the mechanisms of that relationship. Number 11 here, how can we be sure that vitamin D is actually quote-unquote working, i.e. other than clinical response? So let's say you've got a patient who you think is vitamin D deficient. You measure their serum 25-hydroxyvitamin D level. It is what it is, and then you start to administer vitamin D, and you're looking for a clinical response. But what else could you look for in terms of lab testing to give you some appreciation that the vitamin D is either working or not working at the cellular tissue physiologic level? And finally here, number 12, what 3 mechanisms, with at least 2 of those being primary, explain how vitamin D deficiency causes pain? So we'll look at those quiz questions later in today's presentation. Again, right now we're going to focus on external barrier dysfunctions, mostly relevant against viruses and bacteria. So the first step in any new infection is penetration of external barriers, typically the skin or mucous membranes. So as I said in my antiviral nutrition book in 2014, also that information was later published in some other books, especially Inflammation Mastery 4th edition, I talked about looking at viral infections in 4 steps or 4 parts starting off with acquisition, then replication, then immunonutrition, and then integration, which is the cellular and systemic impact of that particular infection. Now, whether we're talking about viral infections or bacterial infections or even allergy exposure, the first step in any of those is crossing the initial barrier, whether that's the skin or a mucous membrane. And that mucous membrane could be in the mouth, in the nose, in the respiratory tract of the trachea, pharynx going down into the lungs, or the mucosa of the genitourinary tract. For any bacteria or virus to initiate an infection, it has to first pass those external barriers. And so if we strengthen or optimize the function of those exterior barriers, then that gives us, of course, a chance to prevent a viral or bacterial infection before it ever has a chance to even start. So let's be optimistic and see if we can accomplish the enhancement of those exterior barriers with proper nutritional supplementation. So again, focusing here on skin and mucosal barriers, we're going to look at the cells, the epithelial cells, which are basically like the bricks in the wall. We're going to look at the mortar or the intercellular junctions that hold those bricks together. We're going to look at the underlying immune system, and we're going to look at the overlying defenses, which is kind of like the paint or the weatherproofing that protects the bricks and the mortar. So the bricks or the cells are the epithelial cells. The intercellular junctions are kind of like the mortar, and then if we were to paint or waterproof that wall, that would be the overlying defenses such as antimicrobial peptides, lysozyme, and secretory IgA, as well as mucus, tears, saliva, and the overlying microbiome. That also serves as a barrier or an interface between the external world and our internal environment that we're trying to protect. So let me give you a couple of metaphors here. Let's say that you are located here and your imaginary enemy is located here. So you're behind a brick wall of cells, and so the cells, the epithelial cells, make the bricks, and then the mortar is made by these intercellular junctions. These are going to be called tight junction proteins, for example, and we'll look at a few examples of those intercellular junction proteins. But again, those are the mortar holding the bricks together, and the bricks are the epithelial cells. Now, you could put more defenses here on top of this brick wall, so to speak. That's kind of like barbed wire, which is analogous to antimicrobial peptides, lysozyme, and secretory IgA. So this is obviously kind of a defensive or military analogy, but let's look at one that's maybe a little more benign or actually constructive. So let's look at this roof that I repaired a couple of years ago. This was the first time I ever repaired a roof, so it's not that great of a job, but I actually had to redo it a couple of years later and did a much better job. So again, we have cells, in this case the bricks, we have the mortar holding the cells together, and then we have kind of a waterproofing or weatherproofing on top of that. Here I was using some really bad material that I later had to strip off and replace. But again, we've got the main structure, we've got the mortar holding it all together, and then we have a coating or a surface on top of that. And then finally we get in touch with someone who knows better than us, and we get some new knowledge and supplement those defenses. So this is just kind of a way of looking at it. What's missing possibly from this image is a better understanding of the mortar. So let's look at another kind of metaphor here. And this is a wall that I'm actually building right now. This is going to be a fireplace when I'm finished with it. But what you can see here are what are called wall ties. And so some intercellular junction proteins actually hold the cells together, but they don't provide weatherproofing or waterproofing. So you can see that these wall ties are holding the bricks together, but they're not sealing the gap, so to speak. Some intercellular junction proteins actually create a tight seal, blocking ions and water, and others just kind of do a loose job, so to speak, of holding things together, as you can see in this metaphor. So anyway, that was just another quick metaphor, and now let's move on. And so as I move on now, I want to talk about the biological plausibility and some of the mechanisms, but we want to remember that all functions basically in the body require all nutrients, even though in this case I am focusing on vitamin D. So everyone needs all nutrients. Most people have multiple nutritional deficiencies unless they are on adequate nutritional supplementation. And so we just want to be aware of those basic concepts as we advance in this conversation, looking at the details related to vitamin D and vitamin D deficiency. So right now, let's dive into those external barriers. Again, skin and mucosal barriers. We're going to look at epithelial cells, junction proteins, underlying immune cells, and then the overlying defenses, such as antimicrobial peptides, lysozyme secretory IgA, tears, mucus, and saliva, and the overlying, again, microbiota, hopefully aiming for eubiosis much more so than dysbiosis, of course. And a lot of times we're not able to separate those, in real life, and certainly not in clinical practice, but we will try to make some distinctions and differentiations. So let's start our review of the external barrier components by focusing in on the epithelial cells, which form the bulk of that external barrier. So when we're looking at the skin, we're mostly talking about stratified squamous epithelium and keratinocytes, and these are active in the disease that we all know about, which is psoriasis. When we talk about the mucosa, we're again talking about stratified squamous epithelium, but with underlying or intermixed goblet and mucus cells. So examples of mucosal surfaces include the gastrointestinal tract, obviously starting with the mouth, the genitourinary tract, and the respiratory tract. So the previous view of these epithelial cells is that they were relatively inactive, and they were just basically bricks kind of stuck in mortar, providing a physical and structural barrier. But now we perceive these cells as being very active and very metabolically engaged and immunologically engaged, and certainly responding against infections and other inflammatory insults. So with the proliferation and maintenance of these tissues, all nutrients are important, but we're going to focus here especially on vitamin D. So again, essentially all nutrients are required for barrier function, maintenance, and regeneration, especially zinc, which is important for protein metabolism, folate, which is necessary for DNA replication, and vitamin A for epithelial maturation and differentiation. Destructive or infectious or inflammatory diseases that necessitate the regeneration of tissues obviously increase nutrient requirements. Nutritional deficiency combined with tissue destruction is expected to lead to, first, reduced barrier integrity, and secondarily to barrier failure. Now let's look at some specific information related to vitamin D. In this article from 2017, we see that vitamin D helps proliferate vaginal epithelium in postmenopausal atrophic vaginal tissue. So I'll start here, as I usually do, by looking at some of the highlights from this article talking about postmenopausal vaginal atrophy. This is typically thought of as being caused by reduced estrogen levels in postmenopausal women, but what they start to do in this article is kind of shift that paradigm and say, hey, maybe it's not just estrogen deficiency, but maybe it's also vitamin D deficiency. The authors state vitamin D influences the regulation of differentiation and proliferation of various cells, especially tissues lining stratified squamous epithelium, such as the vaginal epithelium. Here they looked at samples from 36 patients. They looked at cell-to-cell junction protein expression, which is what I'll talk about on one of the following pages. And they showed here that vitamin D stimulated the proliferation of vaginal epithelium through, of course, the vitamin D receptor, or VDR. So what they noted in this study is that vitamin D is necessary for the proliferation of vaginal epithelium and also for the formation of these cell-to-cell junction proteins, which again we'll look at on one of the following pages. Let's look at another study kind of on the same theme, this one from 2015, the effect of vitamin D on vaginal atrophy in postmenopausal women. The authors begin by stating vitamin D has several important functions which may be effective in proliferation and repair of epithelial tissue. Here they used a vitamin D suppository of only 1,000 international units per application. And they looked at this over the course of 8 weeks of treatment. In the treatment group, the number of superficial cells increased and the vaginal pH slightly decreased. Pain was significantly reduced, so in a lot of women who have postmenopausal vaginal atrophy, they have constant irritation or they have increased pain with sexual intercourse, and so what they're documenting here is not only a change histologically, but also an improvement clinically with the reduction of pain. So they note here that pain significantly reduced after 8 weeks in the treatment group compared to the control group. The mean dryness and paleness reduced significantly in the treatment group versus control at 56 days. Conclusion, vitamin D is effective in improving the maturation index and dryness of vaginal atrophy due to menopause. And let's look at a few more details here. So you can see here that superficial cells increased significantly, intermediate cells also increased very significantly, parabasal cells reduced, and that's a good sign because parabasal cells are considered somewhat intermediate or abnormal or atypical. The maturation value increased significantly from baseline and relative to controls. So again, remarkable improvement here from the application of 1,000 international units topically. Obviously, these women could have been treated not simply topically, or in my opinion, probably they would have had better results if they had been treated systemically. So let's optimize those whole body vitamin D levels and then expect some local improvements as well. And obviously, if a case warranted more assertive intervention, you could apply the vitamin D topically as well as supplement it orally for optimal benefit. Let's continue this theme of vitamin D on epithelial tissue by looking at another study here, this time focusing in on vitamin D and vitamin D receptor signaling on maintaining the integrity of the pulmonary epithelial barrier. Here the authors state that vitamin D and its receptor have a protective effect on epithelial barriers in various tissues. So not simply vaginal epithelium, but also effects in the gastrointestinal tract, and here also looking at specifically lung tissue. Low levels of vitamin D are associated with numerous pulmonary diseases, including acute lung injury and acute respiratory distress syndrome. I'm sure many of you have recently heard of acute respiratory distress syndrome, or ARDS, within the context of talking about COVID-19, the so-called new coronavirus. So what they show here is that VDR knockout mice exhibited severe lung injuries and increased alveolar permeability, greater secretion of proteins, leakage into the alveolar space, and elevated pro-inflammatory cytokines. The vitamin D knockout mice also showed decreased protein expression of these intracellular junction proteins, in this case specifically occludin and zona occludens 1. So I think we can reasonably state that vitamin D and vitamin D receptor activity is important for maintaining the epithelial cell component of these external barriers. So now let's look at another component, which is the underlying or intradermal or submucosal immune cells, especially dendritic or Langerhans cells. Dendritic cells are so named because of their thin appendages which reach toward the surface of the skin or the mucosa to sample antigens. Dendritic cells communicate to other components of the immune system to either promote attack or inflammation or tolerance. So with tolerance, everything is cool, no stress, no inflammation, and the reverse is true if the signal is sent to attack. That alarm or inflammatory signal actually contributes to tissue damage and the further breaching or compromise of these external barriers. So when we talk about, for example, leaky gut or increased intestinal permeability, some of that isn't due to any insult necessarily to the epithelial cells themselves, but actually is part of the immune response that results from the triggering of those submucosal immune cells, which then results in a compromise of the intraepithelial connections or those junction proteins that I've mentioned previously. So again, what we generally want with these submucosal immune cells is that they promote tolerance, because the promotion of tolerance avoids the inflammation-driven disruption of those external barriers. And indeed, just like with the systemic immune system, we do see this with the submucosal or intradermal immune system, and that is vitamin D3 induces tolerance in those immune cells. And you can see that exemplified in this article from Cell Reports 2015. Vitamin D3 induces tolerance in human dendritic cells. In this case, they go on to say by activation of intracellular metabolic pathways. Let's look now at component number 3 of these external barriers. These are the intracellular junction proteins. These include more than 40 different proteins, and just like all other proteins, they are especially dependent on zinc and protein intake. Among the different intracellular proteins, some of them block passage, and so they function kind of like cement or mortar, and others simply hold the cells together but without creating a seal, and so they function kind of like wall ties. And these include zonulin, zona occludens proteins 1 and 2, cadherin and E-cadherin, occludin, and vinculin. In experimental models using human colon cancer cell lines, Treatment with vitamin D increased the expression of some junction proteins, including zona occludens 1, zona occludens 2, occludin, E-cadherin, and vinculin, leading to decreased membrane permeability. And that information was actually recently published in Frontiers of Nutrition 2020 in December. So that's not even a year old. So now let's take a closer look at that exact same article, Zinc, Vitamin D, and Vitamin C, Perspectives for COVID-19 with a focus on physical tissue barrier integrity. You can see the authors state, besides immune cells, the vitamin D receptor is also found in pulmonary epithelial cells. When activated, VDR results in the expression of defensins and cathelicidins. Those are antimicrobial peptides. Those are peptides with antiviral activity through direct action or immunological modulation or immune modulation. They also state that by knocking out the function of vitamin D, animals exhibit increased lung inflammation and impaired lung function, which can be explained by the increased pulmonary permeability resulting from impairment of the integrity of the epithelial barriers. Thus, in vitamin D deficiency, the lungs lose epithelial integrity, becoming more susceptible to inflammatory processes and pathologies such as asthma, chronic pneumonia, and cancer. And you can see this really nice diagram from their article talking about those intracellular junction proteins, here divided into three categories: tight junctions, which are affected by zinc, vitamin C, and vitamin D; adherens junctions, which especially need zinc and vitamin D, and also the desmosomes that are mentioned here. So you can see these tight junctions actually seal ions and fluid transfer, typically water. So tight junctions block ions and fluid, whereas the adherens junctions don't block fluids or ions, but they just hold the cells together, kind of like wall ties. So again, this is kind of like the mortar between the cells or between the bricks, and this is that metal wall tie that I showed you earlier, holding things together but not blocking ions and fluid. And so what we're aiming for conceptually and clinically is to improve the strength of this barrier to block invasive microbes, especially bacteria and viruses, to block them from bypassing these external barriers. So we want to strengthen these barriers in every possible way that we can. That includes strengthening the cells and also strengthening the gaps between those cells, the intracellular junctions. Also, we want to promote tolerance in the immune cells that are below these epithelial cells, because if those immune cells get activated, they will trigger inflammation that will lead to disruption of these intracellular junction proteins, and that will lead to leakiness. And we're all familiar with the concept of leaky gut, and that's what leaky gut is: disruption of these intracellular protein bridges or gaps, or in my metaphor, wall ties. So we need to keep these bricks or these epithelial cells tied together, otherwise we're going to see leaky gut or leakiness of other areas such as the mouth, respiratory tract, or genitourinary epithelium. Let's look at one more article on the same theme, vitamin D3 versus gliadin, which of course is a protein found in gluten, such as in wheat, barley, and rye. And so what they're proposing here is that by strengthening those barriers, we may actually be able to reduce the incidence of allergic diseases generally, and in this case specifically celiac disease. So you can see that this was published in Digestive Diseases and Sciences 2018. Vitamin D is a health-promoting molecule involved in different biological processes and potentially preserving the tight junction structure. Vitamin D metabolite calcitriol, the active form, so to speak, of vitamin D3, prevents the tight junction damage induced directly by gliadin in vitro and in a certain animal model. The findings related to intestinal barrier damage and the benefit from vitamin D use suggest its application in other gluten-related disorders, such as non-celiac gluten sensitivity, where the presence of altered intestinal permeability is proven. So again, this goes back to the image that I just showed you. We're trying to preserve the integrity of first the epithelium, then controlling inflammation that would otherwise be driven by the submucosal or intradermal immune system. And here we're trying to focus in on maintaining the integrity of those junction proteins. When those junction proteins get compromised, that leads to leakiness of these external barriers, the most famous of which is increased intestinal permeability, more commonly known as leaky gut. Let's look at another example on the following page. Vitamin D deficiency contributes directly to the acute respiratory distress syndrome. Also another article showing that vitamin D supplementation provides clinical benefit in patients with COVID-19. Also very well known by now is the fact that patients with severe ARDS, acute respiratory distress syndrome, or those requiring ICU or intensive care unit treatment are frequently very severely deficient in vitamin D. Moving on now, let's go to component number 4 of these external barriers, which are the antimicrobial peptides. These antimicrobial peptides promote lysis of viruses, bacteria, fungi, and cancer cells. They are either pro or anti-inflammatory, but mostly we can consider them to be immunomodulatory. Here from 2017, we see the antimicrobial peptides human beta-defensin and cathelicidin, or LL37, are key factors in innate and adaptive immune responses of the respiratory tract and play an important role in many respiratory diseases. So in human physiology, the two AMPs, or antimicrobial peptides, that you're going to hear most commonly mentioned are beta-defensin and cathelicidin or cathelicidin. Again, these rapidly inactivate many infectious agents. Most antimicrobial peptides act by disrupting the integrity of microbial membranes. The human cathelicidin peptide LL37 is chemotactic for neutrophils, monocytes, mast cells, and T cells. It induces degranulation of mast cells, alters transcriptional responses in macrophages, stimulates wound vascularization, and re-epithelialization of healing skin. That was from Journal of Leukocyte Biology 2003. Beta-defensins are small, cysteine-rich, cationic peptides that contribute to various processes related to both arms of host defense, the innate and adaptive immune systems. That's kind of an old way of looking at the immune system, I might add. All beta-defensins are potent antimicrobials with activity targeting a broad range of pathogens. Some human beta-defensins are also capable of binding and activating specific chemokine receptors. And again, what I want you to remember here is that antimicrobial peptide production is famously dependent on vitamin D. Component number 5 that I'm going to talk about is lysozyme. I'm sure most of you remember hearing about this in grade school or certainly in undergraduate biology. This is an antimicrobial enzyme specifically effective against many gram-positive bacteria. This is excreted in some fluids, most famously in tears, but also on the surface of the skin. Lysozyme levels are reduced with vitamin D deficiency and enhanced with vitamin D repletion or VDR activation. From this article in Frontiers of Immunology, 2020, January, vitamin D upregulates antimicrobial peptide, messenger RNA, and protein expression, including cathelicidin, defensin, and lysozyme. Another article, also published in 2020, stated that loss of VDR functions causes changes in the microbiota and lowers host defense by reducing production of cathelicidin, lysozyme, and autophagy-related protein ATG16L1. Let's look now at a recently published article from Gastroenterology, November 2020. The title of this article is Paneth Cell Alertness to Pathogens is Maintained by Vitamin D Receptors. The authors here state, decreased intestinal VDR significantly correlates with a reduction in levels of ATG16L1 and Paneth cell lysozymes in patients with Crohn's disease. The authors state that the clinical importance of this finding is that targeting the vitamin D receptor affects multiple downstream events within Paneth cells in host defense and anti-inflammation. So basically what they showed here is that vitamin D signaling was necessary for Paneth cells to produce lysozyme. Let's look at this diagram from the article, showing that in the normal situation, the epithelium responds to the microbiome by maintaining some sense of balance between normal physiology and a bit of inflammation that you can see here. When these Paneth cells are deprived of vitamin D signaling, they reduce their production of antimicrobial peptides, and that promotes not only dysbiosis, but also more inflammation in response to that dysbiosis, which of course leads to a vicious cycle. So what we see with dysbiosis consistently across virtually all models and across all species is that it becomes a vicious cycle of microbial imbalance and increased inflammatory response. The microbial imbalance drives more inflammation, but more inflammation also drives the perpetuation of dysbiosis. And some of you may be aware that I detailed that in the microbiome and dysbiosis program that we started back in 2015 and which took me 2 years to complete into 2017. So I'll talk a little bit about that later as related to that video series and the resulting little textbook publication. Now let's talk about secretory IgA. So secretory IgA is the chief immune globulin on mucosal surfaces. It is defensive against infections, but it's also protective or tolerogenic toward beneficial bacteria. Secretory IgA deficiency is the most common genotropic immunodeficiency, affecting about 1 per 600 people. Pleasant short-term stress actually increases secretory IgA levels, but chronic long-term stress actually reduces secretory IgA levels. Many nutrients and probiotics can stimulate or support production of secretory IgA. Remember that with immune globulins, we typically want low basal levels followed by appropriate but not exaggerated increase when faced with a challenge. Also, since we're on the topic of immunoglobulins, I want to remind you that serum immunoglobulins are generally meaningless or at least secondary in the fight against viral infections. Patients with A-gamma-globulinemia typically have normal courses of viral infections and a normal response to viral vaccinations. So let's look at some research related to secretory IgA and vitamin D on the following page. This article was published in 2014, stating vitamin D3 deficiency results in dysfunctions of immunity with severe fatigue and depression in a variety of diseases. And to her credit, this author provides a lot of really excellent detailed information within the scope of only 2 sentences. She states that secretory IgA, another biochemical barrier of skin and mucosa, is supported by vitamin D, rather indirectly by inducing the expression of the Fc receptor on phagocytes, leading to enhanced binding of secretory IgA. She states, furthermore, vitamin D induces CC motif chemokine receptor 10 in human B cells, resulting in enhanced B cell differentiation into IgA secretory cells with the potential for homing to the gut. So you can pause the video if you want to read that again and let it sink in, but she does provide in 2 sentences some really good detail on how vitamin D supports secretory IgA defenses. Now let's take a look at a clinical trial which was recently published in 2015. This is Journal of Sports Sciences. The effects of 14 weeks of vitamin D supplementation on antimicrobial peptides and proteins in athletes. And you can see here from the abstract that the authors state only in the vitamin D group, the saliva secretory IgA and cathelicidin secretion rates increased over time. A daily 5,000 international unit vitamin D3 supplement has a beneficial effect on upregulating the expression of secretory IgA and cathelicidin in athletes during a winter training period, which could improve resistance to respiratory infections. Now let's take a look at one paragraph from this article where they focus in on the effect of vitamin D on antimicrobial peptides and secretory IgA. Antimicrobial peptides are involved in the direct inactivation of viruses through membrane destabilization. They are produced by epithelial cells and macrophages, and in the lungs are secreted into the biofilm covering the inner surface of the airways, thereby creating a barrier that is chemically lethal to microbes. The plasma cathelicidin concentration in athletes with high-level vitamin D status was significantly higher than in athletes with low-level vitamin D status. So what they refer to here as high-level vitamin D status is actually quite good. Anything above 80 is at least adequate, and here they're talking about above 90, so that is actually quite adequate. And here when they talk about deficiency, this is gross deficiency. So what they're showing here in this review of the literature is that higher vitamin D levels correlate with higher levels of antimicrobial peptides, specifically cathelicidin. The authors also state that in addition, the average secretory IgA secretion rate in individuals with high levels of vitamin D was significantly higher than in groups having adequate, inadequate, or deficient vitamin D. So again, in both situations, with antimicrobial peptides and with secretory IgA, we see a dose-response relationship. The higher the vitamin D level, the higher the level of protection from these antimicrobial peptides. Now let's talk about part 7 of these external barrier components. We're talking about protective fluids, including mucus, saliva, and tears. Mucosal tissues secrete mucus, which is a combination of water, the mucin hydrophilic protein, which provides protection and lubrication. Lacrimal glands secrete tears. This is a combination of water, mucin, and lipid, which prevents evaporation and aids in lubrication. Salivary glands secrete saliva, which is a combination of water, mucin, and enzymes and amylase, and all of those, of course, contain secretory IgA and antimicrobial peptides. All of these fluids protect by forming a barrier, removing microbes and irritants and antigens, lubricating and reducing wear, and carrying secretory IgA, lysozyme, and the antimicrobial peptides. Here we see an article from 2020 showing an association between vitamin D deficiency and the severity of dry eye symptoms in primary Sjogren's syndrome. So many of you know, of course, that Sjogren's syndrome is a prototypic autoimmune condition that results in deficiency, we could say, of these protective fluids, including, again, mucus, saliva, and tears. So these patients often present with dryness of the genitourinary tract, mouth, and eyes. And so what this paper showed was an association. Of course, I wish this had been a therapeutic clinical trial, but it just shows the association, as does the following study, which looked at vitamin D deficiency with certain tear parameters in non-Sjogren dry eye. And again, they showed that vitamin D deficiency was more severe in the patients who had drier mucous membranes, and again, in this case, the eye. So when you're working with patients who have dry eyes, dry mouth, dryness of the genitourinary tract, maybe they have an official diagnosis of Sjogren's syndrome, you definitely want to look at their vitamin D status and see if therapeutic replacement of vitamin D provides benefit. Finally, number 8 here, we're going to look at the mucosal microbiome. All skin and mucosal surfaces are colonized with bacteria, fungi, viruses, and bacteriophages. Many of you know my definition for dysbiosis for many years has been that it is a non-acute, non-infectious, or non-invasive host microbe relationship that adversely affects the human host. I've published this in several books and articles. In fact, I think many years ago I originated the idea of multifocal polydysbiosis, and I've also stated that all patients with autoimmune disease have dysbiosis until proven otherwise. When I first said that about 11 years ago, that was kind of a pioneering or radical statement. Now I think it's hopefully pretty obvious. The reciprocal relationships that we appreciate is that health promotes eubiosis and eubiosis promotes health. Inflammation promotes dysbiosis and dysbiosis promotes additional inflammation and ultimately autoimmunity. The immune dysregulation of autoimmunity commonly includes the paradox of immunosuppression with excess inflammation and loss of tolerance. And that leads back to additional dysbiosis, and the dysbiosis again perpetuates immune dysregulation and immunosuppression and more inflammation. So again, all of these are reciprocal relationships that create vicious cycles. Proper nutrition promotes eubiosis, and eubiosis promotes proper nutrition, just like dysbiosis promotes malnutrition, and malnutrition promotes dysbiosis. And speaking of pioneers on this topic, let's look at this article from Margarita Cantorna. She's definitely one of the pioneers in the vitamin D and autoimmune and inflammatory world. This particular article was published 2018, Critical Reviews in Biochemistry and Molecular Biology. Vitamin A and vitamin D regulate the microbial complexity, barrier function, and mucosal immune responses to ensure intestinal homeostasis. Their abstract states, diet is an important regulator of the gastrointestinal microbiota. Vitamin A and vitamin D deficiencies result in less diverse, dysbiotic microbial communities and increased susceptibility to infection or injury of the gastrointestinal tract. Vitamin A and vitamin D regulate the expression of tight junction proteins on intestinal epithelial cells that are critical for barrier function in the gut. These nutrients also support the innate lymphoid cells that produce interleukin-22, suppression of interferon gamma and interleukin-17 by T cells, and induction of regulatory T cells in the mucosal tissues. So this goes back to what I showed you before when I talked about dendritic cells. Those can become more tolerant if they have adequate levels of vitamin D. So we call that a tolerogenic phenotype as opposed to a pro-inflammatory or autoimmune phenotype. So let's look at some of the human clinical trial data, as I'll show you on this page. This is a very recent article titled "The Potential Role of Vitamin D Supplementation as Gut Microbiota Modifier in Healthy Individuals." Subjects in this study were administered vitamin D in the form of vitamin D3, 50,000 international units per week. So that's about 7,000 international units per day for 12 weeks. Vitamin D deficiency affects approximately 80% of individuals in some countries, and they should have said all countries, and has been linked with gut dysbiosis and inflammation. Here we administered vitamin D to 80 otherwise healthy vitamin D deficient women, measuring serum 25-hydroxyvitamin D levels in blood and characterizing their gut microbiota pre and post supplementation using 16S rRNA gene sequencing. They show that vitamin D supplementation significantly increased gut microbial diversity, specifically the Bacteroides to Firmicutes ratio increased, so typically you want more Bacteroides and less Firmicutes, along with the abundance of health-promoting probiotic taxa, Akkermansia, and Bifidobacterium. They conclude, altogether, our study highlights the positive impact of vitamin D supplementation on the gut microbiota and the potential for the microbial gut signature to affect the vitamin D response, and we'll look at that from the perspective of another article in just a moment. Now let's take a look at an earlier clinical trial. The first one was from 2020. This one's from 2016, European Journal of Nutrition. Effects of high doses of vitamin D on mucosa-associated gut microbiome vary between regions of the human gastrointestinal tract. Again, this was also a human clinical trial, and you can see that they used reasonable doses of vitamin D3. The authors conclude, vitamin D modulates the gut microbiome of the upper gastrointestinal tract, which may explain its positive influence on gastrointestinal diseases such as inflammatory bowel disease or bacterial infections. So again, what we're looking at in totality is that making sure that people have enough vitamin D supports their epithelial cells, their submucosal or intradermal immune system, the production of antimicrobial peptides, the production of junction proteins, the production of lysozyme, the production of secretory IgA, and probably is also necessary for the production of normal levels of tears, mucus, and saliva. So we're seeing multiple benefits at each of the important levels or components of these external barrier defenses. Now, related to the gut microbiome, let's take a look at an article that investigated the relationship between vitamin D receptor expression and probiotic bacteria. So you can see the title of this article is "Vitamin D Receptor Pathway is Required for Probiotic Protection in Colitis." Let's take a look at some of the details from the authors here, stating, we report that probiotic treatment is able to enhance vitamin D receptor expression and activity in the host. So again, what we're looking at here is another reciprocal relationship. Vitamin D promotes a healthy microbiome, but a healthy microbiome, here exemplified by probiotic supplementation, also enhances the reception and function of vitamin D by increasing the expression of the vitamin D receptor. So we see this circular relationship where vitamin D promotes a healthy microbiome, and a healthy microbiome promotes healthy vitamin D reception and metabolism. And with that, we have now reached the end of today's presentation, focusing in on vitamin D deficiency manifesting as external barrier dysfunction, and the converse of that is that vitamin D repletion or supplementation should be used to support optimal function of these external barrier defenses. So my summary in the form of a royal decree here is that vitamin D deficiency impairs every aspect of barrier defense, and therefore vitamin D repletion or supplementation to support barrier defense among a general population with more than 80% vitamin D deficiency and patient populations with 90 to 100% deficiency should be the enforced standard of care. And this is, again, highly relevant whether we're talking about viral infections that start with acquisition or penetration of the virus. So step number one is that the virus has to be able to penetrate into the body. It has to be able to pass the skin or pass the mucosal membrane. If we could stop the virus here, then we wouldn't have to be concerned about the other consequences of a viral infection, which are replication, immunonutrition, and the cellular and systemic impacts. So rather than, for example, relying on hand gels and face masks, we should, or at least we could, be focusing in on supporting population-wide external barrier defenses by supplementation with vitamin D to support every aspect of these external barriers, starting with the epithelial cells, to the immune system, to the intracellular junctions, to the antimicrobial peptides, including secretory IgA on those skin and mucosal surfaces. So what I would hope that we might see at some point in our human history is that when we talk about disease prevention, and especially against so-called pandemic infections, we should be talking about strengthening barrier defenses so that these viruses never have a chance to enter. Now, with bacterial infections, first of all, a lot of bacterial infections follow viral infections. So I'm sure many of you are familiar with the fact that a lot of times people start with a viral infection, it causes enough damage so that then a bacterial infection can enter and continue this inflammatory, destructive, and infectious process. But when we talk about viruses, we're talking about viral acquisition, which means penetration, replication, immune response, and immunonutrition, and then the cellular and systemic consequences. With bacteria, those, of course, also have to be acquired, or they have to be able to penetrate into the body. They do their own replication, so they don't need the human machinery to support their replicative process, but we can still fight those off or defend against them either preventively or therapeutically with immunonutrition and cellular and systemic support. So let's bring this to a close right now. We'll finish with the quiz that I introduced at the start of this. How does vitamin D function? By changing gene transcription and, of course, many other pathways and physiologic responses as well. Where does vitamin D function? Mostly at the nuclear vitamin D receptor, also at the mitochondrial vitamin D receptor and the plasma membrane vitamin D receptor, which I talked about in some level of detail in video number 2 when I talked about mood disorders and depression. How does vitamin D function on a quantitative level? It changes transcription for at least 200 genes and perhaps up to 3,000 genes. What's the physiologic effect of vitamin D? To modulate and reduce intracellular calcium levels, and again, changes in gene transcription. What's the minimal cutoff level of 25-hydroxy vitamin D between deficiency and sufficiency? My favorite numbers are 32 nanograms per milliliter, which is equivalent to 80 nanomoles per liter. What is the most common result of administering 400 international IUs to an adult patient? Basically a false sense of adequacy, minimal benefits, and ongoing deficiency with vulnerability to pain, depression, and infection. If we give them 800 international units, they're slightly better, but still pretty vulnerable. At 4,000, we start to see some legitimate and measurable improvements, even better going as high as 10,000 international units. Name 3 nutrients that work closely with vitamin D and the mechanism of that relationship. With magnesium, we see mutual enhancement. So vitamin D promotes magnesium absorption, and magnesium promotes vitamin D metabolism. So magnesium helps vitamin D, and vitamin D helps magnesium. With vitamin A, they both improve barriers, they function at the same receptor, and they also increase epithelial integrity, intracellular junction proteins, and secretory IgA. With vitamin K2, we receive benefit in terms of the function of calcium-containing proteins, calcium distribution, and cardioprotection. And we could also add NAC and glutathione here because those are very important for antioxidant defenses, and vitamin D also plays a role in glutathione metabolism. Question number 11, how can we be sure that the vitamin D is working on a cellular level? What lab test could we use? And I think the test that's going to become more popular in the future is looking at parathyroid hormone levels. And finally here, question number 12, what 3 mechanisms explain how vitamin D deficiency causes pain? These are osteomalacia or subperiosteal edema. Number 2, central sensitization or neuroinflammation. And the third answer could be hyperinnervation, followed by dysbiosis, inflammation, insulin resistance, obesity, and autoimmunity. So again, if you look internationally, we're talking about 40 to 90% of the global population is deficient in vitamin D, and that causes consequences, chronic pain, chronic depression, and increased susceptibility to all types of infection. We have a very detailed understanding of how vitamin D works, and we really have no excuse for failing to treat this among the population when we see so many patients deficient in vitamin D, and we certainly have reason to believe that their clinical picture will respond to vitamin D, and increasingly we have clinical trials to prove that therapeutic relationship. So we need to get everybody on board with vitamin D supplementation. I encourage you to download this 2004 monograph that I published. Here we are 17 years later, and this still remains a very reliable document. So again, you can download this for free. In that article, I introduced how vitamin D was relevant for many clinical diseases that we see, such as seizures, epilepsy, depression, chronic pain. And since the publication of my article, we now have follow-up evidence showing that indeed vitamin D is important against chronic pain by reducing bone pain and central sensitivity, as well as central sensitization. I showed you in video number 2 how vitamin D deficiency manifests as mood and brain disorders. We looked at this article connecting vitamin D with depression, looking at the cellular and regulatory mechanisms. This is an authoritative article by Michael Berridge where he shows you exactly how vitamin D functions, and it's by controlling intracellular calcium levels by increasing the production of this plasma membrane calcium pump. He published that review in 2017, and I also showed you an article that I published back in 2006, which you can also download for free online. This article, Intracellular Hypercalcinosis, a Functional Nutritional Disorder with Implications for Trigger Points in Chronic Pain, Affective Disorders, Hypertension, and Cancer. Again, you can download this for free off the internet. Now let's have a quick clinical review of vitamin D deficiency in adults. What you look for in the history is dark skin, obesity, older age, malabsorption, inflammatory bowel disease, sunlight deprivation or overprotection, chronic use of anticonvulsants, or prednisone derivatives. You might also ask about bone pain, muscle pain, fatigue, depression, infections, dysbiosis, falls, cognitive impairment, and statin intolerance or statin-induced myalgia. Objective findings, you look at pain at periosteal surfaces, especially the radius, tibia, and sternum. You look for global symmetric muscle weakness. You would confirm the diagnosis by looking at serum 25-hydroxyvitamin D levels, after which you would apply the appropriate diagnostic code, treat appropriately, and follow up appropriately, just like you do with everything else in clinical care. I've provided guidelines for the interpretation of vitamin D studies back in 2004, 2005, and again in 2017. So I'm hoping, again, that we can get everybody on board with optimizing vitamin D status in themselves and in their patients. And I think that if we do that, we're going to see many benefits against pain, depression, and infectious, autoimmune, and inflammatory disorders. So what I just showed you is how vitamin D is important for essentially every aspect of our external barrier defenses. In upcoming videos, I'll focus in with a little more detail on autoimmunity, allergy, and metabolic inflammation. Thank you very much for your attention. This has been Dr. Alex Vasquez.